Hey guys, today we'll be doing an implementation of a circular array queue. We'll be continuing our discussion and video series on Java data structures. So we'll be working in the circular array queue class. I've already created it. So if you haven't done that yet, just pause the video and create it. I'm using IntelliJ. I have a main class and then our interface that we created. See the previous video if you need that, or just pause the video and copy it. I'll have our exception class that we created as well. So we'll start coding. So public class circular array queue of generic type T. And up here we'll just import java.util.arrays. Here we can just say, excuse me, actually we can just put it up here. Just put some javadoc and we'll say circular array queue of generic type T represents an array implementation of a queue in which the indexes for the front and rear of the queue circle back to when they reach the end of the array. So if you don't know what a circular array is, it's basically just an array that at the end of the array it just circles back. So it's kind of like a big circle. So we'll just start with the constructor. Actually, before that we'll write some instance data. So I'll try to do a diagram on this. There's no node, so we technically don't really know it. If you are interested in what it is, I'll try to include that in the notes. If not, you can just Google a circular array on Google Images and you should see it just looks like a big circle with indexes. That's all it is. So here we'll start with the instance data. So we'll say we'll create a private final static variable of type int. We'll call it default capacity. We'll set it equal to 10. Actually, no. I'll just set it equal to 5. Just so we can go through something small first. And then private int front, rear, and then count. So all ints. So we have our front reference and our rear reference. Notice how it's not an object reference variable like in the linked implementation. We don't need to do that. So then we'll say we'll create a private T array queue. Remember, objects of type T can't be instantiated, so we'll be casting it in a sec. So here we'll say creates an empty queue using the specified capacity. At param initial capacity, the initial size of the circular array queue. So here we'll write the constructor, so we'll just say public circular array q, and then parameter int initial capacity. We could have just put size there. That's fine. We'll set here front points to rear, points to count, points to 0. I don't know. Personally, I wouldn't. Like, I'm not sure why the book did that, but I'm using the book Java Foundations, the code examples. Sometimes I change them, but you don't really need to do that, but maybe it's just to put everything on one line. So it's just saying initially front points to rear, rear points to count, and count points to 0, so they all point to 0. Just another way to say it. So here we'll set q, the array q, cast it to a t array of a new object of size initial capacity. And it's going to say we're going to need to put this here for that color thing to go away, the warning. So here we'll say add suppress warning unchecked. I think that there's S here. Okay, now it's gone away. So that's just a java.doc command, I think. So then now we'll create. So here initial capacity, I think you can choose that. We can just type one in. So it's going to take an int initial capacity. Then it's going to use the yeah, it's basically just setting the initial capacity with a parameter that when you create the queue, then we're going to create a size. But it's interesting that there's no other variable here, and we didn't use a this or another variable to set it. Usually use a this keyword to set the field. But we'll just try that way first. So we have this, and then we'll create another constructor here. We'll say creates an empty queue using the default capacity. So this is another way to set it up with the this keyword, but it's just referencing this default capacity. So public circular array q constructor overloaded. Then here we'll just call this keyword and say this default capacity. So all it's saying is call this constructor here and pass in default capacity for initial capacity. That's all it's really doing. We can double check that with the we can do a walkthrough with that in the debugger if we remember. If not, you can just do that yourself. But we should try that as well, because this one is this our first constructor, this is our second constructor, and this one's overloaded. The way that it's overloaded because this one takes a parameter, this one doesn't. Then we can create another one that takes 2 parameters. We create another one that takes 3 parameters, and so on. I think you can also use different types for the parameters, and that would also, you can overload them like that. I think you can try that and see if it works. So now we'll add an element to the, we'll do the enqueue method. So we'll just write some java doc here, and we'll say adds the specified element to the rear of this queue, expanding the capacity of the queue if necessary. So there is one thing that we should discuss quickly that's going to help us. So can I just make a note somewhere, like right here? Okay, so I have some I wrote some notes out for this to help you guys with mod division, because this is going to use mod division. So if you forgot mod division, because usually you do that in like your first Java class, it's like one of the first few chapters and you don't really look back on it until now. You might have used it a few times in a few simple problems, but you probably won't be using it until you're doing in a circular array. So remember, the mod division just gives the remainder. So we'll be using this symbol. So we'll do 3 examples, one that's less than, one that's equal to, and one that's greater than, with different integers. So we'll say 6 modulus, or mod 10. What does that equal? That equals 6. Because 6 mod 10, what's the remainder of? So if you take 6 and you say modulus 10, which is, just say remainder 10. So pretend like you're dividing, so 6 divided by 10. What's the remainder of that? Well, 6 divided by 10, the remainder of that is 6. So anything less than what you're trying to modulus is going to be the same thing as what you're trying to, what's going to be the first element. So you're just going to have to memorize it or make a note and check it if you need to refer to it. Excuse me, that's what I did. So there's that. Then we'll say 10 modulus 10 equals to 0. So if you say, okay, I'm going to take 10 and divide by 10 to get the remainder, well, what's 10 remainder 10? 10 divided by 10 is 0, so there's no remainder. 6 divided by 10, it's like 0.6. But remember, with without the decimal, it's going to do just that kind of division where it doesn't do decimal points. Whole division or something. I forgot the name. But 6 divided by 10, it's a fraction, so it's just going to be what it is. And then something remainder itself is going to be 0. Just remember that. And then something, a bigger number modulus a smaller number, is going to be, it's going to actually work normally. So if you take 9 and we're going to say, okay, take 9 and divide by 8 and give me the remainder, well, that's going to give us 1. Right? Because it's going to be like 1.333 or something, I don't know, if like that, something like that, right? I don't know if that's exactly right, but it's just as an example, 1.3333 is going to take those 3's away and just take the 1. So if you take like 10 modulus 8, it should be 2. Something like that. So just, you can use the debugger to check, because it will give you a check, and you can also create a separate class and just do system.out.println the number and what you're trying to mod, or just create variables and just do a simple calculator program or something. So we'll keep that and refer to it. So here we'll just write the code for this thing, for this method. So just remember that that's all you really need to know. If you're going to take a test on this, you don't really need to know the diagrams. I mean, drawing a diagram, just, memorize it's a circle. 1's the first index, 0th index, and it just goes around in a circle, right? So public void enqueue t element takes a parameter t element. We don't have our size method, but we'll just call it here. So if size if size is equal to q.length, expand capacity so it's excuse me, so it's asking for two methods we don't have, and it's like, well, I don't have those methods, so what am I supposed to do? QUEE, so we'll just skip that for now. Personally, I would like to have these brackets here. I don't know why it's auto formatting it like that. So expand capacity, so if the size is not equal to the q.length, the array dot length, then we'll say q of index rear points to element, rear points to, I think is there a typo here? Sorry. Let me just check my notes real quick. No, seems fine. It just seems like the textbook has a typo in it. I feel like one of these should be front, but that's okay. So if size is equal to q.length, expand capacity, q of rear points to element, rear points to rear plus 1, modulus q.length. And that's my bad there. I think I don't need these, because that would be making it a string method. So remember, this one's the string method and this one is the array method. So rear points to rear plus 1 modulus q.length. That's fine. And we'll say count plus plus. I feel like one of these should be front, because y is in front getting set. But we'll come back and see if we have a problem with that. So q of index rear points to the element q of index. I guess they're all pointing to 0 here. Front, rear, count, all point to 0. Then here we say q of index 0 points to element. Honestly, maybe we could have just said 0 here, and then rear points to rear plus 1. So what's rear plus 1? So 0 plus 1, 1 modulus 5 in this case. So we check this, 1 modulus 5. It's just 1, because we're taking a smaller int and modulusing it to a bigger, something greater than. So we're just going to get itself. We have our notes up here. So if its rear is 0, or no, rear equals to rear, which is 0, plus 1. So 0 plus 1 is 1. 1 modulus 5 if we're using 5 as our length. Then rear is 1. So I guess maybe it is okay. Optionally, you could you could also set the front. You could, what's the word? Like specify or explicitly set front to 0 here. Or you could use even front here as well. Should be working the same. You can double check. So that one should be fine. We'll come back to it. We'll come back to it when we debug and do a run through. So that should be okay. And just remember, we're going to be doing these methods in a sec. So I hope you understand. So we're on the next one now. we'll just write some Java doc. So it creates a new array to store the contents of this queue with twice the capacity of the old one. So here it's a private method, so it's a support method. We'll call it, you don't have to make it private, you can change it. We'll just call it expand capacity. We'll create a T array. Whoops. T array. So you can use the same one, but for some reason when you do that, it might not print it correctly, because I remember when I was doing that for my hash function, it was not expanding it, so I had to create a second array, and just copy it in and then print the second one. But you could see what I mean by that is, like, if we were just gonna say queue, or array queue, right, equals the arrays.expand method, you can also do that. The arrays.copy of that method. If you use the same name for some reason, it just it creates a second memory location for the array, and it kind of gets confused. So the best thing to do is create a new array. We'll call it larger, and then you can use we'll cast it here to T array, and then we have to do it this way, new object, queue.length times 2. And also, again, you can use the arrays.copyOf method. Personally, I would do that because I just remember that. Arrays.copyOf, it takes the old array, something like that. You can check it on Java Oracle Docs, and then you can just say queue.length. Same thing here for the second parameter, queue.length multiplied by 2, or you can just put a number in there. So that works as well. Personally, I would do that because I can remember that on the fly more easier, because I use that a lot. So here we'll create a for loop, and it's asking us to suppress the warnings again because it's getting confused, so we'll just do that. Add suppress warnings unchecked. I don't think there's a capital. Okay, that's gone now, and then we'll say for int scan equals to 0. Scan is less than count. Scan plus plus. Honestly, we could just use I. It's a lot easier. Personally, I would use I because it's easier for me to remember. And I'd use J for a 2D array. But here we'll just say larger of index scan points to queue of index front. So larger of index scan points to queue of index front. Then front points to front plus 1. Front plus 1 modulus queue length. I might do a diagram for this one as well, just to help, just in case if you're not 100% understanding. Then here we'll just set front pointing to 0, rear pointing to count, and then queue pointing to larger. We'll save that. Again, if we were just to change these to I, let's just see how it is. So let's just change that. I equals 0, I is less than count I plus plus, larger of I. So let's just take larger now and just call it array 2 or Q2. Actually, we could leave it larger then. So T array larger points to casted T array to new object of Q.length times 2, so 10. That's going to be 10. So it's going to set larger to a new array of size 10. That's all it's doing. Then we'll say for int I equals 0, I is less than count I plus plus. What's count again? Count is, I guess count, yeah, just counts just for size. So I is less than our size, so it's going to copy the current elements. I feel like if you're expanding it, then why would you do count? Wouldn't you just use the default capacity, whatever? But that, I guess you can use either or. So if I less than 0, I is less than 5, I plus plus, larger array of index 0 points to the Q of front, then front. So if Q of front is 0, then let's just say we're storing 5, 6, 11, 13, and like 10 million again. Then we'll say so Q of front is going to be 5. So their new array copied the element over to index 0. Then we'll say front points to front plus 1, so it's going to say front points to 0 plus 1, so now it's at 1. So 1 modulus Q.length. Is just, if the second element's greater than, then it's just going to be itself. So that's all it's really doing. It's just copying the elements. I don't really see the point of modulusing it, because we're just copying the elements. We're not really adding anything else, but that's okay. So front points to 0, rear points to count, and then Q points to larger. So that's just the way they did it. We pretty much just got one more, and then a few smaller methods. So we'll do the DQ. We'll do some Javadoc, so it removes the element at the front of this queue and returns reference to it. Reference to it. We'll say at return the element removed from the front of the queue. Add throws empty collection exception if the queue is empty. We'll say public T DQ. DEQ UE. We'll say throws empty collection exception. Whoops. We'll say here if is empty. Throw new empty collection exception. Pass in the string queue. You can put circular array queue, whatever. Again, we don't have is empty yet, so we'll do that in a sec. T result points to Q of index front. So remember, we DQ from the front and we NQ to the rear. Then we'll say Q of index front points to null. Front points to front plus 1. Modulus Q length. Q to length. And we'll say count minus minus. Return result. That's it. So we'll just double check. So public TDQ throws empty collection exception if is empty. Throw exception. Again, we'll use some brackets here. Just change it up a bit. Then here we'll say T result points to Q of index front, so result points to the first element in the queue. Q of index front points to null. So we don't have to change any links here. We can, since it's an array, we can just directly set it to null. Then we'll reset the front reference to point to the next element. Then we'll decrement count, so front moves to the next element. So basically we delete, we get a reference to the front element. We set the current front to null. Then we move front to front plus 1. We don't have to set any pointers to it in the first place and all that stuff. So it's kind of easier than the linked list, minus the point of going around in circles. Excuse me. So now we'll just do the next method. It's just the first method, so we'll say returns a reference to the element at the front of this queue. The element is not removed from the queue, so it's unchanged. At return the first element in the queue. At throws empty collection exception if the queue is empty. So public T first throws empty collection exception if is empty. Excuse me, we'll throw new empty collection exception of array index Q. Then we'll return Q of index front.